Okay, the quadratic equation has two distinct real roots. And then condition for distinct real roots, real and distinct, when the discriminant is greater than naught. So b squared minus 4ac has to be greater than naught. So identify a, b and c from the quadratic. A is the coefficient of x squared, so a is equal to 2. B is the coefficient of x, which is 3k minus 1, and c is what's left over, 3k squared minus 1. So substitute these values into the discriminant formula. So b squared, so that's 3k minus 1 all squared, minus 4 times a is 2, times c, 3k squared minus 1 greater than naught. Expand out, square the first bracket, square the first term. Square of 3k is 9k squared. Multiply them together and double it. Minus 1 times 3k is minus 3k. Double that is minus 6k. And finally square minus 1, that's plus 1. Minus 4 times 2, so minus 8 bracket 3k squared minus 1 greater than naught. Let's expand the next bracket. Minus 8 times 3k squared is minus 24k squared, and minus 8 times minus 1 is plus 8 greater than naught. So we've got 9k squared minus 24k squared, so that's minus 15k squared, minus 6k, and I got plus 1 plus 8, that's plus 9 greater than naught. Now 3 is a factor, and I want to change that minus to plus, so I'll divide by minus 3. So remember, when I divide or times by a negative number, this inequality will change the other way around. So minus 5 shared by minus 3 is plus 5. Shared minus 6 by minus 3 is plus 2. And 9 shared by minus 3 is minus 3. And that inequality now has to go the opposite way around, because I was dividing by a minus sign. And there's the condition. And now I want to find the values satisfying this inequality, so I'm solving this inequality. Okay, if you didn't arrive at that in a question, you can pick it up from here to get the full marks on the last part. Okay, so to factorize this, I'll do this two ways. 5k and k has to be that, and it has to be 1 and 3. So if I put a 3 there and a 1 there, then I got 5 and 3, 5k, 3k, so that makes 2k. So I want the 5k to be plus and 3k to be minus. So I can show you another factorizing on that. You can also do it like this: 5k all over 5. Then 5 times 3, that's 15. So I'm then looking for two numbers to multiply to give 15, take away to give 2, which is 5 and 3. And that'll be plus 5 minus 3. Take the common factor out of these brackets on the top line. 5 is a factor on the top one. That's 5 bracket k plus 1. The second one doesn't have a common factor. Over 5. And they cancel off. And it gives me the same factor. Okay, to get the key values, k will be 3/5 and k will equal minus 1. So there's two key values, so I need to draw a sketch. So this quadratic curve will cut at minus 1, and that's 3/5. It's positive, so it's going to look this way around. And I want to know when it's less than naught, when use your line where this is where it equals naught. So less than naught is below the line. So for it to be below the line, it'll be that side of minus 1 and this side of 3/5. So it's just between minus 1 and 3/5. So the solution will be k belongs from minus 1 to 3/5. And for the brackets, because that's a strictly less than, I can't take these values, so it'll be a round bracket.